Again, I've got the book here, but I've written down kind of a distilled question. I've taken the question in the book. So I'd appreciate it, just like you saw yesterday. I make errors at times. Just make sure that I've got the question reflected correctly. If you see any typos, I appreciate you catching them and being excited to be, hey, I recognize this was wrong. It's a win, right? It's a win for you. It's a win for me. It's a win for anybody else that may be watching along with us. So, practice problem number 5. If you remember this question, they give you the dimensions of a box and they asked you for the volume of that box in cubic meters. You had to, first of all, remember that you needed to know a formula for the volume, which is length times height times width, those 3 different dimensions. And they asked you for that volume to be in cubic meters, not cubic centimeters. Okay? If you took 23 times 45 times 38 centimeters, the answer would be in cubic centimeters. Okay. So simply multiplying those 3 factors, the units, it's a derived unit of cubic. It's a derived unit of cubic centimeters. Centimeters times centimeters is centimeters cubed. 23 times 45 times 38 is 39,000. Are you done? Well, no. Obviously, the units you were asked for were cubic meters, not cubic centimeters. So you have to have a conversion factor of translating it from cubic centimeters into cubic meters. So knowing that 1 centimeter is 1/100th of a meter, that's my statement of equality that's going to become a conversion factor. And there is the setup. 39,000 cubic centimeters times a conversion factor of 1/100th of a meter is equal to 1 centimeter. But note we had to cube it. Had to be a cube. And we have to cube it because we have cubic centimeters. If I multiply 39,000 cubic centimeters by a conversion factor of 0.01 meters over 1 centimeter, just one of them, not cubed, but just one of them, my resulting units would be centimeters squared meters. You see that? I need to have this 3 times. Now I could have written it times, and technically, yes, that should be a 0.01. That's maybe a typo, okay? You should have a leading 0 for the decimal form. But I could have it 3 times. I could have this conversion factor times the same thing again, times the same thing again, in order to eliminate cubic centimeters and convert it to cubic meters. The shorthand for that is the same thing 3 times is that whole thing cubed. That gives me a resultant of 0.039 cubic meters. Okay, so we finally got to the place where we have an answer, potential answer, right? Now that we're in junior chemistry / math, we ask a question. This is what my calculator tells me. Is my calculator right? Does it know more or less than I do? Hopefully it knows less than you do. All it does is take the numbers you give it and perform operations. So by taking 39,000 and multiplying it by a conversion factor of 0.01 divided by 1 cubed, it gives us this number, but we know that the answer should be to 2 significant figures. So ask yourself that question. What should my answer look like? If I'm doing an operation that is multiplication, I'm talking about significant figures. So multiplication and division, I'm talking sig figs. Addition and subtraction, I'm going to look at precision. Okay? So since I used an operation of multiplication, I know I'm talking sig figs. How many sig figs should my answer be in? Well, going back to my initial measurement, 39,000 cubic centimeters, that came from all of those, right? My volume, if I look at that, how many significant figures are in each one of my digits that made up my volume? 2. Okay? So when I get that answer, for us, luckily, it gets 39,000. How many significant figures are in 39,000? 2. There had to be 2. Because of this math, there had to be 2. And because of this math now, there also has to be 2. How many significant figures do we have in that answer? 2. So it's correct. That is the answer. Okay? So again, the elementary math would be to know 23 times 45 times 38, multiply that by a conversion factor cubed, and now the science part that we're adding to that is what form should my answer be in? How many significant places, or to what precision should my answer be in? Okay. Questions on practice problem number 5? And again, if you did it, you should have it in front of you. See what you did. Compare what you did with what you see up here. See where they're not the same. Okay? And hopefully understand why they differ. Number 6 is basically to convert 71.0 cc's into liters. So represent that same number. What conversion factor or what statement of equality do I need to know? Okay. Do you recognize a cc? Ma'am? Right, 1 cc, first of all, is equal to 1 milliliter, and 1 milliliter is equal to 1/1000th of a liter. Okay? So the key that's not going to be obvious is the cc. cc is not a standard abbreviation for something within the metric system. Okay? It's not, the cc, that c, we may not recognize that as, it's not a base unit for us in metric, right? So it may escape you. Just know that cc stands for cubic centimeters. It could be written as 1 cm cubed. It's a cubic centimeter. It's a centimeter by a centimeter by a centimeter. That dimension is also the definition of a milliliter. So 1 cc by definition is 1 milliliter, which by definition is 1/1000th of a liter. So I'm going to take my 71.0 cc's, and because it's a one-to-one relationship, I can translate that immediately into 71.0 milliliters. And now that I'm in milliliters, I'm converting to liters, and I have my second half here, this statement of equality on this side, from which I create my conversion factor. So again, I'm going to liters, so I have liters over milliliters. Milliliters times liters over milliliters is going to give me liters, which is what I'm looking for. And when I do the math, my calculator spits this out. Now, the only thing I've done here is multiplication. And I've multiplied by a definition. Okay? Everybody with me so far? The only operation I've done is multiplication, and I've multiplied by a definition. So since I multiplied by definition, it does not affect the number of significant figures that'll be in my answer. Therefore, my answer has to be in the same number of significant figures as my original, because I used multiplication. But it has, no, so multiplication and division, I'm looking at sig figs. Because I only multiplied by a defined relationship, my answer has to have the same number of sig figs as my original measure. So we should have 3 sig figs because we're looking back at the original measure of 71.0, and it has 3 significant figures. Ma'am?
Okay, so I know I looked at this math a lot, but I typed 11 and I got like 0.071, but it didn't have the 0 at the end. Yeah. So what?
It doesn't have the 0 at the end?
No.
Okay. Again, that's your device, your calculator. Some scientific calculators are going to add zeros. This is to the right. You can stream as many as you. And some account for it, some don't. I can't speak to your specific instrument. Depends upon, again, your instrument there. But if we were to write it in this way, let's assume that we all wrote it that way, we would still need to go and check it. See, because it needs 3, how does this need to be represented? Right. It needs to be represented with 3. How many sig figs does this have? Pardon? It has 3. So if you wrote down 0.071 without the 0, it would be wrong. So that's where you've got to look at it and say, I need to have 3 sig figs. If I look at this, I have two leading, those don't count. I have two non-zeros, and I have a 0 to the right trailing that's right of the decimal point. I have 3. So if my calculator had told me 0.071, my calculator is not accounting for the fact that I have to have 3 sig figs. And you would have to know to go back in and add the 0 to get the appropriate answer. So each one of these, 5, 6, 7, no, not 7. So I think it's probably 3, 4, 5, 6, 9, 10, both parts of 10, 11. We all get to this place where we compute a number and then we stop and go, okay, is my answer reflecting the correct number of sig figs, and is my answer reflecting the appropriate precision? Did I use multiplication and division? Okay, does my answer represent the appropriate number of sig figs? Using addition and subtraction, does my answer represent the appropriate precision? And then change your answer so it reflects correctly. Okay. So that's that's number 6. Moving on to 7. Convert. Okay, kind of like, now that we've done 2 of those, we'll move away from it for a minute and then we'll come back to it. So we'll mix it up a bit. Convert the following to scientific notation. Whether you're, again, you've got your paper on it. The first one. Remember, scientific notation, we have 2 basic rules of converting from decimal to scientific notation. The first rule has to do with the number of digits that are going to be to the left of the decimal point. And it's going to be 1 non-zero digit. Remember, that's going from decimal to scientific notation. The scientific notation has to have 1 non-zero digit before the decimal point. Going from scientific notation to decimal, we may need to add a 0 before the decimal point. Okay, so that's the difference between the direction you're going. Remember, you cannot have a decimal form that does not have a leading 0 before the decimal if it's actually less than 1. You have to have a 0 decimal and then your numbers. So in this, we're going from decimal to scientific notation. So to comply with that first rule of only having 1 non-zero digit before the decimal point, how do I have to move the decimal point from this number, number 1? Moving it 1 place to the left, which means it's going to appear to be 1.245000. I moved it 1 to the left, which means I raised the exponent from a 0 to a 1. I brought it up 1. Now, this is the one I had a typo on. What do you think I forgot to do? Yeah. Yeah, I cut the zeros off. I had 1.245 times 10 to the first. And it was just going through it and checking it one more time. I went, you know what? I made a student error. Because a student would say, trailing zeros, they don't count. Yes, they do. And they count because look at the number you're in the decimal form. You're converting from. You have to go through and designate which of those numbers are significant and which are not significant. And make sure that your scientific notation represents every significant digit. Now, over here, 12.45, so those first 4 digits are non-zero digits, they're significant. Are the 3 trailing zeros significant? Yes, they are. They're trailing zeros to the right of the decimal point. So they are significant. So they have to show up in my scientific notation. If I don't include them, I'm cutting information out that needs to be there. Number 2. My first non-zero digit is the 3. So I'm going to move the decimal place to be behind the 3. In order to do that, I'm moving it to the left, the implied decimal place, moving it to the left 6 places. So I'm taking a large number, making it smaller. So in my exponent, I need to take a small number and make it larger. So 3.04 times 10 to the 6th. So looking at this number, the 3 is significant, the 4 is significant because they're non-zero. There are no leading zeros, so we don't have to worry about that. We do have a 0 between 2 significant digits, so it is significant. And the trailing zeros, they are not significant because why? Go ahead. They're not to the right of the decimal point. There is no decimal point. It's an implied decimal point. So only the 3, the 4, and the intermediary 0 between them are significant. And so only those 3 digits show up in your scientific notation. If I were to add zeros after the 4, I'm adding information. That's not correct. On the first one, by leaving the zeros off, I took away information that I needed to have. Okay. Probably should get moving because it's a short day today, right? So, number 3, 6.1, because I had to move it 1, 2, 3, so I raised the exponent by 3. But on the left, every single digit is significant, therefore every single digit needs to be in my scientific notation. And lastly, the first non-zero digit is a 1, so I'd expect it to be 1.234. And all of these non-zero digits are significant. Everything else is a leading 0, and it's not significant. I had to move the decimal 3 places to the right, so I'm making a smaller number look bigger, so my exponent needs to make it look smaller. I go from 0 and I make it look smaller by 3. Creates a times 10 to the negative 3rd. Okay. Questions on decimal to scientific notation? There being none, go the other way. From decimal, or from scientific notation to decimal form. First one I'm going to have a 6, right? And 9 zeros. And no decimal point. Because if I add a decimal point, I can't end with a decimal point. I'd have to add a trailing 0. And that would make every 0 significant. Okay? This is where I said yesterday, sometimes it's confusing when you write a number like this, such as 6 billion. Okay? And if it's the last thing you write in a sentence and the decimal point is in your sentence, some people, it's a period, but some people interpret that as a decimal point. It's not. It's a period. That doesn't, so if it's in text, that doesn't make those zeros significant because it's a period. It's something other than a decimal point. So there is no decimal point, there is no trailing 0, because if we did that, that would make all 10 of those additional places significant. And we're not going to do that. That's adding way too much information. The second one. How am I going to move the decimal place based upon the exponent? To the left 3 places. And I have to have a leading 0. I can't have nothing decimal 0, 0. I've got to have a 0. Every digit that's on there is significant because, remember, for scientific notation, every digit represented in your initial scientific notation is significant, and therefore it has to show up in your decimal form. So this 0 has to show up. Because if I were to take that number and work it back the other way, if it weren't there, it wouldn't show up as being significant, and I've lost information. Okay. 1.56 times 10 to the 21st, I'm taking that decimal and I'm shoving it to the right 21 times, and so there's barely room for it on the board. But there is no decimal, there is no 0, because if I do that, I've just made 22 places significant, which aren't significant. Okay? Actually, by moving it that, I would have made not 22, but would have made 20 places significant, which aren't. And lastly, 4.50000 times 10 to the negative 7th. I'm going to be moving the decimal place to the left 7 places, and every digit on there needs to show up, in addition to the leading zeros I need to create to write it correctly, which is why it looks like that. You have to keep those 4 trailing zeros in order to not lose that significance. About 11 minutes. We've got 3 problems. One that has 2 parts. Here we go. Converting Celsius to Fahrenheit. Dum, 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 dum. Not that you are. I'm just saying. Dum, 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 dum. Because I would normally say, stupid, 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 stupid. No. Convert 85.6 degrees Celsius to Fahrenheit. We have a formula for that. Celsius is 5/9. Quantity, Fahrenheit minus 32. Make sure as you come in tomorrow, you've got to have equations memorized, these 2 equations. The one for, this is equation 1.1. Equation 1.2 is the Kelvin-Celsius relationship. You need to have those 2 memorized. Okay? Make sure when you write this down that you remember when it's Celsius using Fahrenheit that there is a quantity, the parentheses around Fahrenheit minus 32. It's important. That means you're going to do this Fahrenheit minus 32 before you apply the coefficient in the front, right? Before you multiply by 5/9, you're going to figure out what Fahrenheit minus 32 is. If those brackets weren't around there, you mathematically would do 5/9 times Fahrenheit first for your order of operations, and then subtract 32, and you get the wrong answer. So make sure you do Fahrenheit minus 32 first, and then multiply by 5/9 to get Celsius. So in this case, though we're converting from Celsius we need to solve for Fahrenheit. And so I walk through that process here. This is as if I'm solving for Celsius given Fahrenheit, but I need to solve for Fahrenheit given Celsius. So I need to rearrange the formula. Actually, from this step, I just wrote it the other way because we're used to seeing what we're looking for equals in formula form. You notice here, it's not quantity. It's 9/5 times Celsius, then add 32. So that bracket's important. The parentheses are important. Celsius equals 5/9 quantity Fahrenheit minus 32, and Fahrenheit equals 9/5 Celsius plus 32. So now that I have it in the appropriate form to solve for Fahrenheit, I go and plug in my variable, my degrees Celsius. I was given 85.6 for Celsius, plugging it into the formula. So Fahrenheit equals 9/5 times 85.6, and then I add 32 to give me 186.08. 186.08 degrees Fahrenheit. That's what the calculator would tell you, but now we know we take one more step of thinking, right? It's either going to be based on sig figs or precision. Which is it? Try again. Because the addition of 32 is by definition, and definitions do not affect precision or sig figs, right? So, right. So, we're also going to look at what is the only measurement in here that doesn't come from a definition. Is 85.6. 85.6 has 3 sig figs, and we have both addition and multiplication taking place, right? But the multiplication, this number is involved in a multiplication, then an addition. So sig figs is the key. 85.6 has 3 sig figs. Therefore, my answer has to be in 3 sig figs. How many sig figs do I have in the current answer? 5. Right? 186.08 has 5 significant figures. I can only have 3. So, 1, 2, 3, I need to figure out what to do with the 6. Either leave it as it is or round it up. And since the tenths place is a 0, it stays the same, so the answer becomes 186 degrees Fahrenheit. You may think that 186.08 is more correct. Mr. Baker, you're throwing away information. 186.08 is more correct. No, it's not. It's less correct. It's less correct because you're implying more information than is actually there to get that answer. So the correct answer is 186 degrees Fahrenheit because it can only have 3 sig figs. And just go back to, on these formulas, I encourage you, go back to your original measurement. How many sig figs did your original measurement have? 3. Everything you did to it was based upon a formula that has exact relationships. Therefore, none of that is going to change it. But remember, when you talk about Kelvin, the Kelvin, that 273.15, that is not exact. So it will affect sig figs and precision. 5 minutes left? Is that true?
We get out of the 15.
That's what I thought. Okay. You guys know this stuff better than I do. Even though this is my only class that I teach, it's different than last year. So I still look at the clock and I look to the minute hand more than I look to the hour hand, so it throws me off, especially on chapel days when everything's thrown off. And I'm used to being first period where my schedule never changed, even on chapel day. So again, I've been spoiled up until this year. Number 10, 2-part question. Convert Kelvin, 396 Kelvin, into degrees Celsius. I'm going to walk through this quickly. I apologize for that, but I'd rather have it, cover it than take it nice, real slow. Every principle you're going to hear in this, we've covered. It's just, this is a particular application of it. So, the formula for Kelvin, I have to rearrange the formula for Kelvin to put it with regard to Celsius, because I'm converting to Celsius. So I need to write it as Kelvin minus 273.15. When I plug in the number, 396 minus 273.15, my calculator tells me it's 122.85. However, I'm smart enough to know that my answer must be precise to the ones place. Why? Because my operation is addition or subtraction, isn't it? And my operation of addition or subtraction is using 273.15, which I've already learned is not precise, and therefore it does matter in my answer. So, as I look back to that subtraction problem, for addition and subtraction, my answer can only be as precise as my least precise measure, right? As the least precise element in the equation. So I have this answer, which is to the ones place, and I have 273.15, which is precise to the hundredths place. Which one is the least precise? 396 to the ones place. Therefore, 122.85 needs to become 123. So I converted from Kelvin into Celsius, and 396 degrees Kelvin is equal to 123 degrees Celsius. The second part of the problem takes us then from that Kelvin to Fahrenheit. So I'm going to bring the answer that I computed from the first part, knowing that 396 Kelvin is 123 Celsius, and now I need to go from Celsius to Fahrenheit. So I take my formula for that. I've already taken the Celsius formula and converted it to Fahrenheit before. So Fahrenheit is 9/5 Celsius plus 32. If you have a hard time reworking the problem every time in algebra, just memorize it in both forms. Memorize it how you convert to Celsius and how you convert to Fahrenheit if you're just not comfortable with rearranging the formula every time. If you are, memorize one of them and then you can convert back and forth using algebra. So my Fahrenheit's going to be the 9/5 multiple of my Celsius and then add 32. So 9/5 times 123 plus 32 gives me 253.4, calculator says. But, boom, I know the answer must be to 3 sig figs, because I have addition of a defined number, so it's not going to affect precision or sig figs, and I have a defined ratio here times a number which is to 3 significant figures using multiplication. So my answer has to be to 3 significant figures because of that 123, and so 253.4 becomes 253. And sometimes I'll write on paper, like I would write Fahrenheit equals 253.4, and then I would use an arrow. And for me, an arrow means which becomes 253. It's not really right to say equals because it's not the same thing, right? But because I'm applying this rule, it becomes 253. Last one. Should we do it? Boom, here we go. Number 11. The average low temperature in International Falls, Minnesota, which is the coldest place in the U.S., in January is -7 degrees Fahrenheit. What is that in Celsius? So real rapidly, boom. There's my formula to put it in Celsius. I plug in the number, and I get -21.6 repeating. I could put a 6 and a bar over it, right, to say it goes on forever because it's a 2/3. However, my answer has to be to 2 sig figs because my original number is to 2 sig figs, and everything else is by definition. So, since my answer can only be to 2 sig figs, I have multiplication going on here, so it's sig figs, not precision. My answer has to be -22 degrees. Because to put it in 2 sig figs here, it would be these two. What do I do with the 1? I look to the right. It's 5 or greater. I need to go up. That makes it -22. And remember, this -22 is more accurate than this number. In your mind, you think, oh, more decimal places is more accurate. No, it's not. This is more accurate. All right? I'm here all day. If you have any questions, let me know. Otherwise, I'll see you tomorrow.